Water is clearly the most important factor in floodplains. Built structures liable to modify the floodplain hydrology, such as embankments, roads or canals, can have significant impact on the local environment, fisheries and livelihoods. The Tonle Sap existed for centuries with a subtle balance between hydrology, fauna, flora and seasonal variations. The conservation of most species in an aquatic system depends on the maintenance of flood pulses. Any long-term change affecting hydrodynamics, such as timing, height, or duration of the flood, will result in fundamental changes in the ecology of the areas affected. Let us take the example of a virtual lake ecosystem. The seasonal variation allows this tree to live and grow on this piece of land while coping with the seasonal flooding phenomenon. During the rainy season, this inundated tree also constitutes a natural habitat for fish and aquatic animals, insects, reptiles and birds. The tree trunk allows the development of microscopic organisms and algae, which become food for zooplankton and fish. These last elements become food for predators. A food chain is created. During the dry season, leaves will fall. Young trees will germinate and grow and then ensure the survival of the forest species. This natural organisation explains why so many freshwater fish are attracted by floodplains and why these floodplains are so fertile. Without inundation, trees would not shelter so much life, and without trees, water alone would not be so productive. Let's see what could happen if dam construction upstream kept the water level 1 metre higher in the dry season. All the trees that lie down the floodplain would have their roots permanently submerged, even in the dry season, and might die. As their seeds cannot germinate underwater, the forest stand would ultimately disappear. The Tonle Sap water balance is strongly influenced by the Mekong. Almost 60% of the Tonle Sap water comes from the Mekong. 30% comes from the Tonle Sap tributaries, such as the Stonechenit, and rainfall over the lake only provides the rest. Therefore, any upstream development will largely impact the flood pulse in the Tonle Sap system. The most important impacts will be experienced during the dry season. On a basin scale, 87% of well-known fish species are migratory species, and many species migrate between the Mekong mainstream and the Tonle Sap.
Regarding hydrology, our results show that upstream developments will have 4 consequences on the lake. First, they will delay the onset of the flood. The flood will start later. Second, they will shorten the duration of the flood. Third, the area flooded will be reduced. And fourth, there will be a serious reduction of sediments into the Tonle Sap floodplains, and that means a reduction of fertility.
The Cone Falls in Laos is a bottleneck for long-distance fish migration, especially for species that constitute the bulk of the Tonle Sap catch, such as Tre Reo. If any dam is built on the Cone Falls area, this would have a serious impact on fish migrations basin-wide and on Tonle Sap catches in particular. For instance, changes in dates or level of flooding are expected to disrupt the migration behaviour of around 50,000 tonnes of Tonle Sap fish. Basin-wide, the fish resource amounts to a huge 2.6 million tonnes, so a hypothetical loss of a mere 4% of this resource would correspond to 100,000 tonnes, which would already have terrible consequences on the food security and livelihoods of riparian people. In the case of intensive development, the loss of fish is expected to be much higher than this small figure. Natural resources like lakes and rivers can hardly resist increasing demand for water. There are unfortunately some examples of ecological disasters due to mismanagement of natural resources. In South American floodplains, deforestation as well as dams and road construction have been a major issue echoing in world opinion. The Tonle Sap today is far from such degradation, but threats are definitely present and should be seriously considered if its natural resources are to be preserved.